Hi. So I thought I would touch on all the topics we discussed this week in a bigger picture of the universe and our solar system and how it all works together. I was also challenged by a friend to try and explain Olbers' paradox, which I will try and do at the end. So as we said, our universe is nearly 14 billion years old. In the beginning there was a big bang and there was this hot mess of all the matter that makes up our universe. And after about 200 million years, the epoch of reionization happened. Try say that 3 times fast. That was when the first stars started forming and emitting light. And since then, our universe has been expanding. And like we discovered, expanding at an increasing rate all the time. So in our in our universe now, there are hundreds and hundreds of billions of galaxies. And each galaxy has hundreds of billions of stars. There are more stars than there are grains of sand on the beaches of the Earth. Stars are formed, I said, nearly every second, but some calculations reckon that up to 4,000 stars can be formed every second. It's just so hard to imagine how big the universe is, even some of the objects in the universe. So our sun and our solar system sit in the Milky Way galaxy. In the center of our Milky Way galaxy is a supermassive black hole. Most galaxies have black holes at their center. We sit in a little slightly habitable zone almost between two of the spiral arms, and our galaxy is 100,000 light years across. So if you imagine it takes 8 minutes for light to get from the sun to our Earth, that's over 90 million miles in 8 minutes. Can you imagine how far light travels in 1 year? So imagine 100,000 light years across. It is enormous. What I find really interesting is our solar system and what makes it special. So of course it's special because it has the Earth and the Earth has life. But it's the makeup of the whole solar system that supports life on Earth. As we discussed, the sun generates the heliosphere, which is a protective layer of plasma all the way around our solar system. We have 2 very big planets, gas giants, Jupiter and Saturn. And those, because they're so big, they have a big gravity, and they serve 2 purposes. That gravity against the sun's gravity keeps everything in a very neat balance. Our planets circle perfectly in their orbits. They're predictable, and we also are not subjected to many impacts with asteroids and comets because these big gas giants draw them towards them. So the whole makeup of our solar system is quite amazing. The fact that our planet has its magnetosphere that protects us from the sun even, and our moon is really interesting. So 2 early planets in our solar system hit each other, and the moon was a chunk of molten rock that came out of that explosion, and all the little bits that were flying around all formed together and finally cooled as our moon. But our moon is at the perfect distance to sustain life on Earth. Why I say that is because the Earth is on a tilt. And the reason that's great for life is the tilt gives us our seasons. So the Earth turns on an axis. It also wobbles on that axis, but it doesn't wobble too much, and that's because of the stability of the moon. We all know the moon impacts tides, keeps our waters moving. So each part plays a critical role in making our solar system special and able to support life. Okay, Olbers' paradox. So essentially, this is an interesting paradox that has been around for some time, and a number of people have made philosophical and scientific arguments for and against it. What Olbers said was that if the universe is infinitely big, with an infinite number of stars, then the light from those stars should all reach our eyes, should all get to us, which means the sky should be bright, not dark. Even if you look at the sky outside of our atmosphere, there are dark patches and you can make out stars. It's not all one uniformly bright universe around us. So the theory against Olbers' paradox is the Big Bang theory, is that the universe is not infinite, it had a finite start. So not all the stars were formed at the same time, they're not all the same distance from us, and their light suffers redshift, which is something I can explain later because I'm running out of time. But so there are a number of reasons why the light doesn't reach us all at the same time, and the universe is not uniform either. So the Big Bang theory counters Olbers' theory paradox, but it also is almost proof for the Big Bang theory if you're looking from the perspective of Olbers' paradox. So I hope you found that interesting, and I suggest you read up. If you have any inputs on Olbers' paradox, I'd be more than happy to hear. Thanks, and stay safe.